Hello, Mr. Kaczynski with you. Going to do the solution to 3.2 practice your skills. Here we go. We got Percy the rabbit hopping on down the number line here. We're going to write a recursive rule for the sequence of Perry's jump locations. So this only says that we need to keep track of his jump locations. So I guess we'll just write a one variable recursive rule. So where's his starting point there? That's 10. So that's 9, 8, 7. So we'll go 7, enter, and then how much is he advancing? Let's see, 8, 9, 10, 11, 12. So let's see, 1, 2, 3, 4, 5. So we'll go plus 5, enter, enter, so on and so forth. All right, so we could write one to keep track of his jump number and his location, but I think we'll hold off on that until later. Find the missing values in this table. So let's do the recursive rule here. See, this is where I think it makes more sense to write one that actually keeps track of both. Let's do this. So we started at 0 and we said 7. And we're going to take that jump location and add 1 to it, or jump number and add 1 to it, and we'll take the location and we'll add 5 to it each time. So we already know it's 0, 7. And now we just figured out it's 1 and 12. Obviously 2, it's going to be 5 more, which is 17. To get to 37, hit enter a few more times. You can see it's jump number 6. And at jump 12, see, I like this way because now I don't have to count. I don't have to keep track. It's 67 is his location. All right, moving on to number 2. List the terms of each number sequence of y coordinates for the points shown on the graph, then write a recursive rule for each one. All right. So for A, we're just doing the y values. So how about, looks like it's going up by a half each time. It's starting at a half. So we'll go 0.5, 1, 1.5, 2, 2.5, and does it end at 3? Yeah. And then our recursive rule will be 0.5, enter, and then plus 0.5, enter, enter, and so on. And for B, let's see, that one is, we're just doing the y values again, so it's starting at 4, and then it goes to 3, then 2, then 1, then 0. Recursive rule will be 4, enter, minus 1, enter, enter, and so on. For C, we're starting at -1, and looks like we're going up a quarter every time. 1 quarter, 2 quarters, 3 quarters, 4 quarters. Okay, so -0.75, -0.5, -0.25. Then we get to 0, and then positive 0.25. Recursive rule would be -1, enter, and then we're going to add 0.25 every time. That would be our recursive rule. And for D, let's see, what do we start at? -1.5, and then it goes all the way up to 0, and then 1.5, and then 3. Those are our y values. Recursive rule. negative 1.5, enter, and then plus 1.5, enter, enter, and so on. All right. Took us a while, but we got all that. Make a table listing the coordinates of the points in 2B and 2D. I'm going to draw this here. All right, so for B, we got 4, 3, 2, 1, 0, but we're doing the coordinates, so it's not just 4, it's really 0, 4, 1, 3, 2, 2. So we'll list it like this. We'll do X and Y coordinates. And this is for B here, 2B. We're going to go 0, 1, 2, 3, 4. Is that where it ends? Yep. And then these are our outputs that we already know. So it's 4, 3, 2, 1, 0. And then for 2D, we'll do the same setup, X and Y. That also starts at 0, 1, 2, 3. So 0, 1, 2, 3. And our outputs are right there, negative 1.5, 0, 1.5, and 3. Okay. 4 says plot the first 5 points represented by each recursive rule in 4A and 4B on separate graphs, then answer 4C and 4D. So I think what I'm going to do is I'm going to do this on the graphing calculator. So I'm going to enter these points in. We haven't talked a lot about this, but this will be the easiest way for me. So 0, 5 is my first point. And with the first value, the X value, we're going to add 1 every time. And how many points are we doing? First 5 points. So we're going to do 1, then 2, then 3, then 4. So there's our first 5 points. Now I can see here that answer 2, our Y value, is being increased by 7 each time. So we're going to go from 5 plus 7 is 12, 12 plus 7 is 19, 19 plus 7 is 26, plus another 7 is 33. And then I'll turn my scatter plot on, and I'll do a little cheating here. But you could graph, well, you know what, we'll go from 0 to 5 and 0 to 40. All right. And what I can do is do a little screenshot of that. Bear with me here for a second. Throw that in there. It's not going to let me, is it? All right, how about we just recognize there's our graph right there. All right, the next one, we're going to do, it says to do them on separate graphs, but I'm going to do them on the same graphs. Here we go. So let's go to stat, enter. We're starting at 0, so we're still going to use 0 through 4 here, but we're starting at -3 for our Y values, and then we're subtracting 6, so -9, minus 6 is -15, minus 6 is -21, minus 6 is -27. That'll do it. I got to set up my second graph a little bit differently here. I'm going to use list 1 and list 3, and I'll use a different looking mark there. Let's go zoom 9 again. There's our second graph. Okay, so we got all that. Next up, on which axis does each starting point lie? They both start on the y-axis right there, 0 and 0. Okay, so let's go type that in. Each starting point lies on the y-axis. And what is the x coordinate of each starting point? That would be 0. As the x value increases by 1, what happens to the y coordinates in 4a and 4b? In 4a, the y coordinates, I'm just going to type values, that's quicker, go up by 7 each time x increases by 1. In 4b, the y values go up, no, they go down by 6 each time x increases by 1. The direct variation y equals 2.54x describes the relationship between two standard units of measure where y represents centimeters and x represents inches. In other words, there's 2.54 centimeters per inch. Write a recursive rule for a sequence of values of any whole number of inches. All right, well, we're going to end up using it here eventually anyway, so I think I'll go here. 0 inches, 0 centimeters. That would be our start. And then we're going to take the number of inches and increase it by 1. And we'll take the number of centimeters and increase by 2.54. All right, so here is our recursive rule. It's going to be 0, 0, enter. And then answer 1, these are kind of tough to write out. We're going to add 1 to that each time. And answer 2, we're going to add 2.54 to that each time. And then hit enter, enter, enter as many times as we want. All right, use your rule to complete the missing table value. So I already got the 0, 0. When I hit enter, it gives me the 1 and the 2.54. When I hit enter again, it'll give me 2 and 5.08. In other words, 5.08 centimeters in 2 inches. All right, we'll keep hitting enter until we get to 35.56. And that'll give us 14 inches. And then we'll hit enter a few more times to get to 17 inches. And that'll be 43.18 centimeters. All right, check, we're all done. That's it for me for today. And hopefully this helped you. Good luck. See you soon.